Hello, this is Mr. Agbamu Idanogrene. I'm here to solve this question on bearing taken from WAEC 2001 number 12. It's a theory question and a full question. So the question I've already given us a sketch of how the diagram of this question is going to be. But I want us to follow the statement of this question. Let's draw the diagram from the statement. Let's just ignore the diagram that is given first so that you understand how you can draw without looking at the diagram. Okay, let's start without wasting time. The question says in the diagram, alright, we have 3 points A, B, and C on the same horizontal ground. Okay, so A, B, C, they are standing on a level ground, horizontal ground. Alright, so let's start now. So let's locate the point now. It says B is 15 meters from A. Okay, so that is not the direction, it's just the distance. So B is 15 meters from A. So this question is coming from A. So our first thing we are going to draw in this question is point A. So that's where we are going to start with. Let's draw it down. So you get your pen. Let's get point A. Let me just put it somewhere here. You draw your 4 cardinal points. This is the first thing we do in bearing question, and this is point A. You label it point A. Alright, so this is where we are coming from. Let's go back. So we said from A on a bearing of 053 degrees. So the bearing coming from A to B is 053 degrees. So you locate it. So 53 is going to be on this first quadrant here. So we move straight to B. So B is going to be somewhere here. So this is B. Alright, so this angle here is 53 degrees. Very important. Okay, so from A to B is 53 degrees, so take note of that. The angle is very important, and we are moving to B. So let's go back to the statement. Now we are in this place. This is where we are now. Then the next part of the question says C is 18 meters from B. So now you are moving from B to C. Now I've already told you in bearing, always know where you are coming from. It's where you are coming from, that is where you do your angular turning. Facing north and turning through the east is very important. So from B, we need to turn at which angle? On a bearing of 161. So you turn 161 degrees before you go to point C. And if I do that, so I'm on B now. The rule is you are always facing north, which is 0 degrees. Then you turn down. This is 90 degrees. We are turning to 161. So 161 should be somewhere here. Since this line is 180, south is 180, so 161 should be somewhere here. You go straight down, then you can put the value. This is 161 degrees. Alright, so that is this turn. And where are we going to? We are locating point C. So you get your point C. You label it down. This point C. Alright, let's go back to the question to see what it says. So that is all with that. Then the next thing is the length that are given. So B to A is 15 meter. Then B to C is 18 meter. So we have 15 and 18 meter. So this place is 15 meter. Then this place is 18 meter. Alright, so you take note of that. Then what next? Let's see. Then the question says a vertical pole with top T. So there's a pole which the top is labeled as T, is erected at B. So you can see it in the diagram. So there's a pole that is erected at B, and you can see this angle here, 90 degrees. So the pole is really a vertical to the horizontal, that is 90 degrees to the horizontal. So the pole is not slanted at an angle, it's standing vertically to the horizontal plane. So it will be 90 degrees to the horizontal plane. And this pole, the top is labeled as T, and is positioned at this point B. such that the angle it forms with ATB is 58 degrees. Alright, that means I'll come to my diagram. On this point, there's a pole standing vertically like this, so you can assume it's something like this, and the top is being labeled as T. Then the angle between this pole and this ground is 90 degrees and is connected to point A. So if you connect it to point A like this, according to the question, you take it down. All these lines, you need to make it straight. Use your ruler to make these lines straight and neat when you are solving. So that is that. Then what next? The next thing is calculate correct to three significant figures: the length AC, the bearing C from A, the height of the pole. So we need the length A to C. So we are joining A down to this C. So this is the distance the question asks for. Let me label it as D. So this is the sketch of the question. After drawing the sketch, you can make your diagram very neat by using your ruler and making it fine for well presentation. So this is the sketch. So with this, we can solve this question. Remember what I told you in our previous video. I said when you are solving, take note of alternate angles. So this is point A, move to B, and the bearing of from A is 53. So this angle here, this angle is still going to be 53 degrees. That is alternate angle. Take note of that. Then this is 161 degrees and south is 180, so we need to get this angle. So it's just 180 minus 161 is going to give us this remaining angle. So if you do that simple calculation, which is 180 minus 161, is going to be equals to 19 degrees. So take note of that. So 19 to this place is 19 degrees. Then from there we can get the full angle at point B. Very, very important. So this full angle at point B is what? It will now be 53 plus 19. So when we add this one, we are going to have 70 what? We're going to have 72 degrees. So you can check it well with your calculator to be sure you are correct. 9 plus 3 will give us 12. Then remainder 1 plus 5 is 6, plus that one 7, so 72 degrees. So now that we have this angle at point B and it's facing D, so we can use our cosine rule, and the distance AC, which are represented as D here, will be solved, and that one is settled without any issues. So let's solve this one and move to the next part. So that is, we can do the A part now. The length AC is easy for us to get now. Let me move down and solve it here. So AC, we can solve it by using cosine. So using cosine rule, I'm going to have AC. I use D to represent my AC. So D square. So D square is going to be equals to, then remember the rules as I said in our previous video. So D, this length you are looking for is facing this angle, so you need to square this length. So D square is equals to, then you square 15 square plus 18 square minus 2 times 15 times 18 times cosine of this angle facing D. That is what cosine rule is talking about. So which is 15 square plus 18 square minus 2 times 15 times 18 times cos 72 degrees. So that is it. So all you need to do now is just to simplify with your calculator and you are okay. Then D now be equals to, well, let me do everything here directly so that we'll get our answer once. So 15 square plus 18 18 square minus 2 times 15 times 18 times let me use my calculator to do this. Let me use my calculator here to do this. Okay, I have 15 square plus 18 square minus 2 times 15 times 18 times cos 72. So that is the answer, 382.13. 382.13. So I need to find the square root of that. 382.13, and that is going to give us d is equals to what? Let me do that one separately here. Okay, so square root of 382.13 is equals to 19. So AC is going to be 19.548 kilometer. Let me see our question. Is it given in kilometer or in meters? Okay, it's given in meters, so not kilometer. So the unit is in meters. Then we need to know the unit, the approximation they say we should do. They say to 3 significant figure. So your answer in 3 significant figure is going to be what? So since I use AC to represent D, so AC, which is the same thing as D, in 3 significant figures, so it's going to be 19.5 meter. So that is all for AC. AC is settled. There's no issues with AC. So let's go back to the question. Let's see the next thing they ask us to do. So the next thing they ask us to calculate in the question is the bearing of C from A. So when you come from A, if I go to my sketch, so from A now, which is from A, you turn down to this line before going straight to C. So what is the bearing? So if I can get this angle, the bearing will be easy. So if I label this angle as theta, it's easy. So all the bearing will now be 53 plus this angle is the bearing from A down to C. So if this is already 53 plus this angle I'm going to calculate next, then before you move down to C. So that is the bearing of from A to C. So how do we get our theta? Since I've known my D now, I know this length facing theta, I can use sine rule to solve this. Sine rule is very easy. Sine rule is just the length divided by the sine of the angle facing the length. Then 18 is facing this angle. So 18 divided by sine of the angle facing 18. So if I solve that one here, let me also do it in this corner. So if I solve that, remember this is the A part of the question, don't forget. This is the A part of the question. So let's solve the B part here. So the B part, which is the bearing. So using sine rule. So if I use sine rule in this case, so sine rule now we said the angle is facing 18. So you have 18 divided by sine theta. I don't know that angle, by sine theta is going to be equals to, then I've calculated my AC, which is 19 point, I'll use this one, 548 to 3 decimal divided by the angle facing it is 72. So sine 72. So if you cross multiply, I'm going to have sine theta is going to be equals to 18 times sine 72. 18 times sine 72 then divided by 19.548. So let me simplify this with my calculator. Let me see my result. So if I simplify this, I have 18 times sine Let's get our sine 72. This is giving us 17.11, then divided by 17.119017 divided by, let me see the denominator there, divided by 19.548. 19.548. So that is 0.8757. 0.8757. So sine theta is going to be equal to 0.8757. Then if you find the inverse of this, the angle will be settled, which is let me move up a little. That is theta. So theta is now going to be equal to the sine inverse of 0.8757. And if I do this one, my theta is going to be equals to, let me do it in this corner. So I get my sine inverse of 0.8757, and that is 61.12. Let's take it to 3 decimal. 61.129. Okay, 128. 61.128. 61.128 degrees. So that is the angle. Now that I know this theta, all I just need to do to get the bearing to be 53 plus this theta, and that is the bearing from A to C. You can see the turning from the north, 53, down to this place. Then you continue the turning down to this line before you move down. So 53 plus theta is the bearing from A to C, and that is going to be equals to, just a therefore now, the bearing, therefore the bearing of C from A is, bearing from C from A is going to be 61.128 plus 53. Okay, and this is going to be equals to what? Okay, let me just do it here quickly. 53 plus 61.128, and that is 114.128 degrees. So this is our answer. Then since the question says we should take it to 3 significant figure, so to 3 significant figure, I'm going to get the answer to be 114. That is 114 degrees. 114 degrees. So that is it. So it's not really a difficult question. Just follow this question, follow the sketch, and follow the sine rule and the cosine rule. In bearing, just try to learn sine rule and cosine rule. If you know how to apply your sine rule and cosine rule, bearing is very simple. The main thing is to get the sketch. You already know the basic assumption. You must face north. Every point must face north. Then the bearing must turn through the east. So that's how we do our bearing calculation. Then the last one is talking about the height of the pole, BT. So if you go to our diagram, we're looking for this pole, which is BT, the height of this pole, and that is going to be in this place, H. So we are looking for H. So how do we get H now? So let's see. Remember, this is a right angle triangle. So this is a right angle triangle, and we need to get this height H. So okay, if we go to the question, I think this angle is given in the question. I think it's given. Let me go to the question and check. That is ATB. This angle is given in the question. Let's see. Yes, it said angle ATB is equal to 58 degrees. So since this angle is given 58 degrees, so that is the end of this question. We don't have anything to do. So the height we just use our basic trigonometric ratio, which is opposite. So this is a right angle triangle, this is hypotenuse here now. So this is the adjacent side, then angle is facing 15. So 15 meter is the opposite. So opposite over adjacent is going to give us tan 58. So if I do that, which is the part C now, we can do that one in this corner. So part C, question, which is using trigonometric ratio. Using trigonometric ratio, we are going to use tan. So tan 58 is going to be equals to 15 divided by, okay, we use h as our d. I'm using h as my d, so opposite all over hypotenuse. So hypotenuse is the height, opposite is 15. Sorry, opposite over adjacent. Adjacent is the height, the opposite is 15. The hypotenuse is this longer side, which is facing 90 degrees. So opposite over adjacent, and that is tan 58 degrees. So if you cross multiply, this is a simple calculation. H is going to be equals to 15 divided by tan 58. So finally, h is going to be equals to, let me finish it with my calculator. So I have 15 divided by, you get your tangent, tan 58, and that is equals to 9.737. 373 meter. Let me check it again. 373 meters, correct. So that is all, and since we are going to three significant figure, so h is going to be equal to three significant figure is 9.37 meter. So this is the end of the question. Very simple and straightforward. Just know how to get the sketch. That is the beauty about bearing. Follow the question directly, know where you are coming from. You are coming from A, so I started my drawing by sketching A first. So since A is where I came from, I start from A, then I turn 53-degree bearing to B. So that is what we did first. So from A on a bearing of 53 degrees going to B. Then when we got to B, from B now, see, from B we now turn again 161, which is the from B, see, we now turn 161 before going to C, which is 18 meter. Then we now join A to C. Then the question says bearing from A to C. So the question says we should calculate the length AC, which is basic cosine rule. You can do that easily. Then the bearing of C from A. So bearing of C coming from A is this full turning, which is 53 plus theta, and we use sine rule to get our theta and cosine rule to get our length AC. Then the height of this pole is very simple. Just use your tangent in trigonometric ratio, which is opposite over adjacent, to get your height, and that is all. So this is the end of this question 2001 number 12, and it's a full theory question. So that is the solution of the question. Alright, before we go, let me demonstrate it using GeoGebra. Assuming you have to solve this question from scale drawing, you can use scale drawing, you will get the same answer I just got here. All I just need to do is to draw to scale, make sure all the lengths are perfectly drawn, and follow the angle using your protractor. But I'll just use this GeoGebra to make it fast for us. So you can see the 3 points A, B, and C. And according to the question, let's go to the question. We said from A to C we turn 53 degrees. So without wasting time, if I turn my 53 degrees, just be watching my turning here. So 53 degrees. So this is settled. Then you need to move from here down to B. So I need to position my B. But before I position my B, let me put my length so that I'll get my length. Remember the length is 15. Oh, sorry. The length is 15 meter. So let me balance it with the direction. So 15 meter. Okay. Okay, so 15 meter from A, I've settled this. So A to B, turn bearing 53 degrees down to B, and it's 15 meter. Alright, then C, let's go on. Then it said from B now we turn bearing 161 degrees to C. So if I turn 161, so from this B now, which is this, if I turn 161, just watch out with the angle is turning. So when you turn 161, you stop. So 161, you stop. Then we connect them from B down to C. Then let me get my length of 18 meter before I stop. So get my 18 meter. Okay. Okay, let me move down. Okay. Now let me just position it well. Okay. Alright, so I've gotten my 18 meter. So now we can join the length from A to C now. So this is balance. So if I measure my distance, you will see I'm going to get the same result we got from our calculation. This is 19.84. You can see it, 19.84. And in our calculation, what did we get? Let me see. Got in our calculation, okay, we got 19.5. So 19.5. So I think it's just an approximate difference of value. So I got 19.8 here. So if I take it to one decimal, it's going to be 19.8. Then in calculation is 19.5. We are still in order, which is approximately 20 meter to whole number. So we are still in order. Okay, so that is that. Then the next question we solved says we should find the bearing from A. So the bearing from A to C, which we got 114 to whole number to 3 significant figure here. So let's measure it here. So from A, that means I'm going to turn down to this place. So let me return back to 0. So from A, just watch the turning. As I turn down to this place, I'm supposed to get 114, and that will be our answer. You can see it, perfect. 114 degrees. That is the bearing from A, turn down before you move to C. So by watching this kind of animation, this kind of turning, I think you understand what bearing is all about. All you just need to learn is that cosine rule and sine rule for calculation of length and the distance and the angles. Just take your time, go through the calculation aspect. You see that it's not a difficult thing. Just know your sine rule and your cosine rule, and you are okay. Then you can see the turning. We always turn facing north. You turn through east before you move to where you are going to. You face north, turn through east before you move. You can see that we got the same result. 114 from A to C, 114, and that is the same thing we got 114 degrees. Alright, so the other part of the question says there's a pole. So there's a vertical pole placed at point B, and the angle from A, B, C. Let me go to the question so that we can see. It said there's a vertical pole which is erected at B. So there's a pole here, it's standing at B, and the angle from A to B, this angle is 58 degrees. So let me position that in this GeoGebra. You see, by putting a pole on this place, you know this is a horizontal plane here, this horizontal ground. So a pole is on this place, so you are just seeing the top of the pole. So I need to go to our 3D view so that you can see it very well. So with 3D view, you will understand it well. Okay, let me move this so that you can see it. So this is in 3D. You can see point A. Let me take C out of this place so you can see it well. Okay, so this is point C, so this is point A, so A, B, this is point B, and this is point C. You can see the turning. So something like this. Let me make it to face us directly. So this is what I have here. So this is my A, B. You can see the B. This is my A. It has turned 114 coming to C. So this is point C. Then this is the length we calculated. Then this is the previous length we have. Then a pole is erected at this place. So let me put a pole there. So if I put a pole there, all I just need to do, I need to get a vertical, a perpendicular line. Remember, this pole perpendicular. This pole is perpendicular to this plane, to the horizontal ground. So I need a perpendicular line from here on this plane. You can see it. So I've gotten that. But this perpendicular line, the length is what I don't know. You can see that it's very long. So let me just create a point on it. Then that point I will use it to estimate the height. But we need to get the actual angle first. So if I get that point, let me connect it to A. So from A down to this point, so I've connected them. Then I also need a segment from this point down to B. Then let me hide this my long line. I don't need this one to appear. Let me not show it. Alright, so let me remove this plane so that the ground can be clear. So it's something like this. So this is what the question is talking about. You can see the vertical pole that is placed at B. You can see the pole is standing vertically at B. So with something like this, I think the picture of this question will be clear to us. So this is the height the question says we should find. So let me put our angle at angle 58. So the angle between this line and this line is supposed to be 58 degrees. Then you already know that this line and this is 90 degrees. So you can see it's 90 degrees. Let me move it so that you can see it clearly. So this is 90 degrees. I think you can see it clearly when it's like this. I think you can view it well. Hope you can see it well as I am turning it. And so this is 90 degrees. Then this is supposed to be 58. So when this is 58, this height will easily be found now. And remember, the height we got in our calculation is let me go back to our calculation so that we can see the height. The height we got is 9.37 meter. 9.37 meter. So this height, let me place it there. Let me get the distance. So this height, so you can see we got 9.28. Though I've not really put my final 58 degrees. So you see our answer is very close. The answer we got here is 9.37. So I'm still very close, 9.28. So if I position my angle 58, I think we'll get that result. So 58, I need to move gradually. I hope this will balance. So it's not really giving me 58 exactly. So if I try to move it, but it's not moving with my mouse, with my keyboard. So let's just approximate it like this. So 58.05, which is almost approximately 58 degrees. So the angle from A to top T here. So if I show my label T, let me change the name. If I rename it as capital T, okay. So you can see the top T is this. So you can see 9.36. So I have 9.37. You can see we are still very close. It's just because I could not move it. I could not move this angle to be exact. If I can move it exactly 58, I think this would be exactly 37 meter. So you can see from scale drawing, you can actually do this calculation and you are okay and you are in order. So this is the representation of this question. The vertical pole is standing at B. You can see it at B, and the height is 9.36 or 9.37 approximately and these are the various turning. If you put it like this, you see, you cannot see the pole again because it's facing you. You are looking at it from the top, and that is this view. Then when you turn it at an angle, you can see it, and just like that. So this is the end of the question. Let me rotate this work so that you can see it. You can see the rotation. Let me control the rotation so that you can view it gently. That is it. Alright, this is the end of this question. I hope you all understood all I did. Just go through the video again from the beginning and take your time and follow all the examples I gave, and you see that we are okay and we are done. So thank you so much for watching my video. Thank you for always commenting. Thank you for understanding, and I hope to see you in another interesting video. So this is WAEC question 2001 WAEC number 12 theory question. So that is all for now.